Hello, everyone. We are the Data and Democracy team. Our team members are Sally North, Lisa Singh, Klaudia Barbarossa, and Jacob Chui. Starting off with the project introduction. This project is part of the University of Chicago Data Science Institute. Our general project is to consolidate a comprehensive election results repository accessible to the public. To do so, our project consists of three main goals. Firstly, we are tasked with processing data available online in PDF format using large language models to accurately gather historical election data in CSV format. Secondly, working with open elections, a public GitHub project seeking to consolidate election data to incorporate our own data into open elections framework. And finally, creating a public-facing website to display downloadable data. Last quarter, we processed election data from PDFs into CSVs in order to put the data into machine-readable formats. This quarter, we were tasked with making this comprehensive database accessible to users. Hence, our problem statement consists of two parts. One, how can we standardize our process of LLM-based election data collection into one that fits into the open elections framework? And two, how can we present this data to users in a user-friendly manner through a website? The former aspect of fitting our data into the open elections framework is a data engineering problem, whereas the latter aspect of visualizing our data through a website is a data analytics problem. Our final deliverable for this quarter was primarily a website providing users with access to election data from 1920 to 1996.
Now that you have a preliminary understanding of the project, the rest of this presentation will be going over four main subsections to our project. We'll first go over our LLM comparisons and data processing, then our work with open elections, our work with building a public-facing website, and ending with our conclusion. Beginning with our comparison of LLMs. Last quarter, we worked with the Claude API to process the election PDF shown above into a machine-readable format, specifically CSV files. We generated approximately 3,000 files across all 50 states and the U.S. territories containing Senate, House, and presidential data. The columns we included were state, year, office, candidate, party, votes, and congressional district for House races. We then cleaned and standardized the data to fit the open election specifications for data naming, and we repeated the process we had with Cloud on the PDF files with other large language models, specifically ChatGPT.
We made accuracy metrics to compare performance between the two LLMs that we tested. We concluded that Cloud is a superior model for both data collection and OCR when compared to ChatGPT. Although we initially had problems with Cloud correctly reading candidate names due to their variability and length, we were able to improve our accuracy through extensive prompting for the LLM to recognize all candidate names. We then repeated our data scraping and CSV conversion processes in ChatGPT with the same prompts used for Cloud. When we evaluated the CSV files generated through ChatGPT using the edit distance test on string values and numerical accuracy tests on numbers, we found that ChatGPT performed significantly worse than Claude, providing unsatisfactory results for columns with diverse entries such as candidate names and vote counts. Upon further inspection using confusion matrices and error plots, we found that ChatGPT is constantly misspelling candidate names and has an absolute error score that is 3 times worse than Cloud. Here's an example on the vote count absolute error plots of both models. While Claude occasionally had outliers with high error rates, ChatGPT had visibly more outlier vote counts, while with the error score being also far greater than Cloud's. Having confirmed that Claude was indeed the best performing LLM, we were confident to move on to our next step, which is integrating our existing data pipeline with open elections.
Moving on to our work with open elections. Our first problem was primarily a data engineering issue. We plan to work with open elections, whose goal is to create the first free, comprehensive, standardized, linked set of election data for the United States, including both federal and statewide races. We plan to contribute our data to their GitHub repositories as we have federal level data from 1920 to 1996. Initially, we struggled to understand the construction of their repositories, there being 130 plus unique repositories with different labeling styles, data gathering methods, and coding files. For example, some of the data was collected via web crawler, while others were from PDFs the user already had. We decided to focus on the federal level versus uploading data for each state individually, and are now awaiting a response from them to our pull request. Another issue we found with open elections was understanding how previous users worked within the database. Each state was worked on by different people or sometimes multiple individuals, all using different notation and coding standards. There was state specific notation for each party, and some examples for the Democratic Party are given above. Even within one state, different styles of notation was used, making it difficult to understand how to format our data. Due to this issue, we decided to focus on the federal level data versus splitting up state by state to ensure we could maintain one style of notation.
We then forked the official open elections US data repository and added every federal level election results from 1920 through 1996. Once all 50 state CSV files were in place, covering presidential, Senate, and House races, we packaged our changes and submitted a pull request to the open elections maintainers. While we await their review and workflow approval, we've pivoted to building a dedicated website. By doing this, we ensure public access to the archive regardless of the pull request timeline.
And now we're transitioning to speaking on our website. As mentioned, we decided to shift gears and build out a public facing website. This gave us the opportunity to focus on presenting and visualizing the election data we had already processed. Our main goals were to design and build an interactive website that makes the data accessible to the public, to create visualizations that help user explore trends across time, geography, and party, and to enable filtering, exploration, and downloading of our CSVs so users can interact and analyze the data on their own. This step helped us move the project forward while waiting for integration approval, and it also made the work more immediately useful to researchers, journalists, and the public. The first choice we had to make when we were creating our website was whether to use a Jekyll GitHub page or a Dash page for our website. Initially, we planned to create a Jekyll GitHub page. However, members of our group had significantly more experience using Dash, another website creation package. Due to this and the liberty Dash provided with creating more dynamic visualizations, we decided to go with it. We also faced visualization issues, particularly with accurately reading the data that was placed in the wrong column by the LLM, as well as issues with using Altair, as it was an outdated package. So we pivoted to using other packages such as Plotly, and we were to make some initial visualizations. Our website now consists of 4 primary sections: a home page, an about page introducing the team working on the project, the progress made over the past 2 quarters, and additional information, a data page explaining how we collected and processed the data from PDF to CSV and the CSV files themselves, and finally, several visualizations and an election result exploration page, which contains our visualizations, for example, maps and bar charts. Here's a look at the website we built as part of the analytics portion of our project. This is our historical US election data viewer, which allows users to interact with the processed election data we extracted using LLMs. At the top, there's a drop down menu to select the year. Once a year is selected, the site loads a preview of the corresponding CSV file. Users can scroll through the data, which includes columns like state, race, year, candidate name, party, and total votes. At the bottom, there's also a download button that allows users to export the full file for their personal use. This tool makes our work more transparent and usable while we wait on integration from open elections. It also helps demonstrate the potential for broader civic data engagement through clearing design and accessibility.
This is an example of visualization of the House election from 1932 created using Plotly. This interactive visualization allows the user to view the majority party and vote count for each state using the tooltip function. The user can also use the box function to highlight specific states. And moving on to the conclusion. In conclusion, we constructed a website where visitors can browse our data section for per state, per year CSV downloads, dive into the code and methodology docs to understand exactly how the OCR and validation techniques work, and meet our team in the About page. Looking ahead, we aim to integrate this data into the open elections framework using their data architecture. We'll also add interactive time series visualizations so users can explore election trends from 1920 to 1996. Finally, we aim to extend our archive by adding full presidential and vice presidential returns, completing the Century Plus dataset. Thank you.